Hey guys, my name is Newman Waters. I'd like to just quickly go over some questions you might be having about Part 4 of Lab 2. Now, Part 4 of Lab 2 asks you, based on input switches or selects, can you display these different, options? Okay, so I put the first option here, but there's three others, for the four options that you can possibly have for the two select lines. Now, I've created an example here which showcases how you would do this if you just had these very basic options: A, B, B, C, C, D. No, I did A, B, C, D, I guess. A, B, C, D, E, F, and then 0, 1. So it's very similar, but you're going to have to figure out how to extend this out. So I'll kind of walk through how this goes, how this works, and then you can kind of think in your mind how you would build this up. So what I've done here is I have hard-coded these pairs of values, all right, and I've put them into my 8-bit multiplexer because 2 hex digits is 8 bits total. Each one is 4 bits. Now when I select 0, it's going to take in the value at position A, because that's how we created our multiplexer, and it's going to output that. It's going to output this in raw hexadecimal, or really binary, right? And so what is A? It's just 10. So that would be 10 is 8 plus 2, and then B is 11, so that would be 10 plus 1. And this is what we should see come out of our multiplexer. Right, and that's kind of what we see here. We see 1, 0, 1, 0, 1, 0, 1, 1. Right, and that's AB. Now, how did I get this to split out like this? Well, you can use this component called the splitter. Now, you can take out this wire here, and it gives you an 8-bit output. But we want each individual bit, so we use the splitter, and we say it's taking in 8 bits because that's how wide the thing that comes out of this multiplexer is. And we want it to split out into all 8 bits. So we type in 8 in the fan out. And since these, the top 4 represent this number here, which is the lowest, hex digit, we want that to display to our lowest hex digit here. So we're going to attach those 4 wires as our binary input to our 7-segment decoder, which in itself will, have 8 signals that get sent out to the hex digit. And then the same thing for this 7-segment, which is taking in the uppermost hex digit and it's converting it into a signal that can be understood. And again, this is the hex representation, or this is the binary representation of the mapping that you did in the 7-segment component that you made. Now, think about how you might extend this when you need to display these other options, such as D1 and then the other ones, right? Because you're going to need 4 hex digits. So there's multiple ways of doing it. You could technically copy all this stuff, but we really want you to be typing in like D1 here and having it come out as D1. That's the biggest thing, is that we don't want you to take in that mapping of that big truth table that you did and just say, oh, the letter D has this code, right? It has this code here. I guess this is the letter A. The letter A has this code. Let me just put this code 88 straight into here, right? That's not what you're supposed to be doing. You're supposed to be typing it out as it will look. But there is this internal processing that you need to do to get there. That's about it.